Let's now look at questions B3 and B4 from our 2018 final exam paper. So what we have over here is basically what we're trying to do is we're trying to find the bearing size that is required at support C and support O. And what happens is we've got two gears, gear A and gear B. Gear A is acted upon by a force Fa, which is given as 11 kilonewton. On gear B we have a force Fb. So what happens is, in order to solve this problem, the first thing that we'll do is we have to solve for force Fb. So when this type of problem is given, we need to always draw a free body diagram. And then what we are also required to do is to find the reactions at support O and C. And once we have the reactions, with respect to the reactions, we can find the bearing size. And in order to size the bearing, we are to take into account some fundamental quantities. For example, the shaft is going to rotate at 100 revolutions per minute. It is to be operated for 20,000 hours. The application factor is given as 1.1 and the combined reliability is given as 0.95. So we covered in our lectures that when combined reliability is given, we find the reliability of each bearing by just doing nth root of your combined reliability. So in this case, n is number of bearings, in this case 2. So 2 root of 0.95 is basically square root of 0.95. So later on we'll get these values in. So the first thing that we need to do is, as mentioned earlier, we have to find our force Fb. This is our y-axis, this is our z-axis, and this is our x-axis. So in order to solve for Fb, we can take sum of moments about the x-axis around the x-axis counterclockwise to be negative. So this is what I'm doing. Sum of moments about x-axis counterclockwise is positive is equals to 0. Then what happens is we need to identify what component of Fa is going to cause a moment about this gear A. So when you look at Fa is acting at 20 degrees with the horizontal. So we see that the horizontal component of Fa is going to cause a moment about this gear A. When we look at Fb, opposite, this is your adjacent and this is your hypotenuse. So again you identify that the horizontal component of Fa, which is going to act in the positive z direction, is going to cause a moment about gear B. When we're looking at Fa, we'll see that again the horizontal component of Fa, which is acting in the negative z direction, is going to cause a moment about this gear A. So what we do is we take sum of moments. So we have 0 is equals to horizontal component of Fa is given by Fa equals 20, and this force is acting on this gear which has a diameter of 600 mm. So sometimes what happens is you can take the radius or you can take the diameter, but you'll notice that I'm taking the diameter of the gears over here. I'm not taking diameter and radius over and then radius over here. Both of them can be diameters or both of them can be radius. And you can also notice that I'm just taking mm because once I solve for my Fb, you'll see that mm and mm, it is F equals 20 times 600 divided by 300 cos 25. You'll see that these units cancel out, but for me I would recommend that you use your SI units. So what happens is, if horizontal component of Fa is going to cause a moment clockwise, so it's negative, so that's why I have a negative. Fb, horizontal component of Fb is going to cause a moment in the clockwise direction, so I have a plus. So once I solve for Fb, you get a value of 22.18 kilonewton. So that was the first step to find your unknown force Fb. Now what happens is, in order to solve for your reactions, we have to convert this given diagram to a free body diagram. Now what we do is, when we look at Fa, don't worry about your reactions at the moment at O and C. First look at Fa and Fb. So you see that Fa is given horizontal component x in the negative negative z direction, and the vertical component x in the negative y direction. So this is what I have. The vertical component of Fa is given by Fa sine 20. So Fa sine 20 is acting in the negative y direction, and the horizontal component of Fa is going to act in the negative z direction. So that's what you have here. So it is given by Fi cos 20. In the similar manner, when you look at Fb, the vertical component of Fb is simply Fb sine 25, which is acting in the negative y direction. So it is indicated over here. And the horizontal component of Fb is going to act in the positive z direction, so which is given by Fb cos 20. So these two are basically just trying to get its components in the horizontal and vertical direction. So this is something very, very important. Now when you look at your reactions at O and C, again in MM211 we said that if you don't know the direction in which the forces are acting, we assume them to act in the positive axis directions. So you'll see that I have put ROZ in the positive Z direction and ROY in the positive Y direction. Same thing with your reactions at support C. So RCY is acting in the positive Y and RCZ is acting in the positive Z direction. So done. So once your free body diagram is important, if your free body diagram is wrong, then that means that the calculations that will follow will be wrong as well. So now let's look at sum of moments about point O around Z axis. So this is basically trying to take sum of moment around point O around your Z axis counterclockwise is positive. So what we have is, so let's look at what causes moment about the Z axis around point O. So we've got Fi sine 20 and it is going to be a negative value because it's clockwise. So negative Fi sine 20 times the distance, which is 0.4, minus what we have is we have Fb sine 25. Again it is going to cause a moment in the clockwise direction, so we've got negative Fb sine 25 times distance from O is now 0.75 meters, and finally we have ROY, which is going to cause a moment in the counterclockwise direction. So this is a positive over here. So what we have now is the distance of ROY from the origin at O is 1.05 meters. So now the next thing is that you calculate all of these and write them individually. So minus Fi was 11 kilonewton, so minus 11 sine 20 times 0.4, so I get a value of negative 1.504. then minus Fb sine 25, so Fb was 22.81 kilonewton, so substitute there, find sine 25 times the distance of 0.75, so you get a negative 7.23, and then finally plus 101 RCY. Then what happens is you can solve for RCY because you can make RC the subject of the formula, and then you get that your RCY is 8.32 kilonewton. You'll see that it's a positive value, and what this positive indicates is that the direction that we assume for RCY is correct. Now what we can do is we can solve for ROY. I can solve for ROY just by taking sum of forces in the vertical direction. So basically I'm taking sum of forces in the y direction. If it is acting upwards is 0. So what I have is I have ROY. So ROY minus, since Fi sine 20 is acting in the negative y direction, minus Fb sine 25 is again acting in the negative direction, and then plus RCY. So you substitute for all of these values. So ROY minus Fi sine 20 minus, we got negative 3.76, Fb sine 25 you got negative 9.64, and then RCY was whatever we obtained from here, and what we get is we get a value of ROY to be 5.08 kilonewton. So what this indicates is that again the assumed direction of the force ROY is correct. Now let's look at our forces in the taking moment about this should be y over here. For some reason this y has moved on. So what we're doing is we're taking sum of moment about point O around the y-axis counterclockwise to be 0. This y has moved for some reason from here. So this is sum of moments about point O around the y-axis. So what we happens is, now looking at around y-axis, so we're looking at forces acting in the horizontal direction. So the first thing is, you have got Fi cos 20 and it is going to cause a moment in the positive direction, so that's why you have Fi cos 20 times distance is 0.4. Next we have Fb cos 20, it is going to cause a moment in the clockwise direction, so we have negative. And then finally Rcz is going to cause a moment in the clockwise direction, again minus. So what we do is we calculate these values. So 11 cos 20 times 0.4, you got a value of 4.13. 22.81 cos 25 times 0.75, you got a value of 15.58. Since it's negative in the clockwise direction, don't forget to put that negative sign. So once we solve for Rcz, we get a value of negative 10.83 kilonewton. So what this negative indicates is that the assumed direction of Rcz that we started with is supposed to be in the opposite direction. So Rcz is actually acting in the opposite direction, not in the positive z but in the negative z. But we don't have to change this over here, leave it as it is. We can solve for ROZ by taking sum of forces in the z direction, and then forces to be positive, it is acting in the positive z direction, so we take them to be 0. So the first thing is we've got ROZ. Then you'll see that Fi cos 20 is acting in the negative z direction, so minus. This is acting in the positive direction, so that's why I have a plus Fb cos 25. And then the assumed direction of Rcz in the beginning was positive, so leave it as it is. These equations are written, all of these equations are written with respect to the free body diagram you had in the beginning, so don't change this to be a minus Rcz, just leave it as it is. So ROZ we don't know, minus Fi cos 20 is negative 10.34, plus Fb cos 25 we got plus 20.67, and we had a plus Rcz, but we know that Rcz was a negative, so that's why it comes and substitutes as a negative value, and then you get your Rcz to be 0.494 kilonewton, and it's a positive value, so it indicates that the assumed direction that we start off for ROZ is correct. This is very important over here. Don't change this equation over and put negative Rcz, because you got a negative Rcz value in the previous step. Put it positive, because with respect to your free body diagram, Rcz is acting in the positive z direction and it should be a plus. Once you're substituting the values over here, you actually found that your Rcz was negative, so then substitute that value over here. That's very important that you keep in mind. Now the next step is to find the resultant at the two supports. So let's start off with support O. So the first thing is, your reaction at O is nothing but ROYJ plus ROZK. So you got 5.08 in the Y direction and 0.494 in the Z direction. So this is in kilonewton, so you can leave it as that. And the resultant is nothing but ROY squared plus ROZ squared holding square root. So your resultant at support O was 5.10 kilonewton. Now this formula is something that you need to know. What we have is, we've got let's look at the bearing that is required. You are to select a angular contact bearing at both supports O and C. So now what happens is, for angular contact bearing, this was 1 over I is 3, so that's why you've got 3 over here. Then what happens is, this is XD, and XD is nothing but your multiple of rating life, which is nothing but 60 times ND divided by 10 to the power of 6. Your speed was given as 100 revolutions and the rated life was for 20,000 hours. So you obviously get a XD value of 120, so substitute over here. Your application factor was given as 1.1. Since we're finding the bearing size at support O, I'm using the reaction at support O as 5.1 kilonewton. Once I evaluate that, I get a catalog rating C10 value of 37.9 kilonewton, and for this the bow size is 55 mm. I will indicate later as to how I got a bow size of 55 mm and how to read the tables. Same thing for support C, the resultant was 13.66 kilonewton. substituting into the equation for finding your C10, your catalog rating, substituting everything appropriately, you get a C10 value of 101.51 kilonewton, and the bore size corresponding to this catalog rating is 90 mm. So I will tell you as to how to select your bearings. So now what happened is, at support O your C10 value was 37.9 kilonewton. So this is your Engla contact bearing column. So you look for a value of 37.9 kilonewton. I can't use 37.7 because it is under rating, so my bearing will fail. So the next option is to use a bearing which has a C10 value of 46.2 kilonewton, and corresponding to this the bore size is 55. Same thing for support C, the C10 value is 101.51 kilonewton. So I will choose a catalog rating of 106 kilonewton, and corresponding to this the bore size is 90. So that's how you select the bearings on both the supports. In this case it does not specify select one bearing that can be used for both the supports. If that was the case, then you would have used a bearing with a bore size of 90, because at support O it would have been able to sustain the load of 101.51 kilonewton, and in support O it would have been almost 3 times the required. But I cannot choose a bore of 55 and use it at support C, because it can only cater for 46.2, but at support C my catalog rating is 101.51 kilonewton, so it would have failed. So in this question it says select the bearings at O and C, so you can select them individually. The question was to select a bearing that can be used for both the supports, then your logical choice would have been just 90. Now let's look at question 4a, which is dealing with clutch analysis. So it says that a single plate clutch is required to transmit 20 kilowatt. So this 20 kilowatt is your power, and it is to transmit this 20 kilowatt at a speed of 2000 revolutions per minute. So that's the speed at which the clutch has to rotate. If the coefficient of friction is given as 0.2 and the ratio of diameter is given as 1.5 and the maximum pressure is given as 150 kilopascal, and assuming uniform wear, so this is very important, this is a qualitative data that you are to look for. Uniform wear case, we are to find the inner and outer diameter of the frictional surface, and then finally the actuating force. So what happens is you have to be very careful. In this case it says the clutch plate is required to transmit, so it has just one friction surface. It does not talk about two friction surfaces. If it is said that, it would have read something like this: a plate clutch which is effective on both the sides. So in this case n is 2, but in this case n is 1. We given the diameter ratio. So this diameter ratio is the outer diameter divided by inner diameter. So capital D divided by small d is equals to 1.5. So what we have is, we list all the knowns. So power was 20 kilowatt, the speed was given as 2000 revolutions per minute, the coefficient of friction was given as 0.2, the diameter ratio, that is the outer diameter divided by the inner diameter, was given as 1.5. Therefore the outer diameter is 1.5 times the inner diameter. Your maximum pressure was given as 150 kilopascal. So what we know is that power is equals to tau omega, and omega is 2 pi n upon 60. So basically the first thing is you can solve for your torque. Torque is nothing but power divided by omega. So what happens is, the power is given as 20 kilonewton, your omega is basically the angular velocity was 209.44. so your torque equated to be 95.49 Newton meter. With this torque, we already know we have a uniform wear case, so this is the formula. So normally what happens is, in front of this equation, all of this is multiplied by n. N is the number of friction surfaces. In this case, number of friction surfaces was just 1, so you don't see any n multiplied to this equation. So torque is 95.49 Newton meter. As such, coefficient of friction is given as 0.2, pi, Pmax was given as 150 kilopascal, times your inner diameter is d divided by 8. Then what we have here is, we've got your outer diameter, and your outer diameter is nothing but your inner diameter times 1.5. So this is what I'm substituting over here, minus your inner diameter. This is where students make a lot of mistake. It is 1.5 small d. It's 1.5 small d whole thing squared. Some of you will put 1.5 d squared minus d squared. That's wrong. Just be very careful. It is kept outer diameter squared. So your outer diameter was 1.5 small d. All of this is squared. So it is 1.5 d times 1.5 d. So that is very important. Now what happens is you can move on to the next step. So what I did is 1.5 squared minus 1.5 times 1.5. You get 1. Let me just do that calculation quickly. 1.5 times 1.5, you get 2.25 small d squared minus small d squared. So you simply end up with that. You get 1.25 d squared, but you have another d over here, so that's why you get a cubed here. So that's how I got to this. And then now making small d the subject of the formula, I get my inner diameter to be 0.186 meters or 186 mm, and your outer diameter is nothing but inner diameter times 1.5. So your outer diameter is 0.28 meters or 280 mm. Your actuating force is given by this formula for uniform wear. So pi p max small inner diameter divided by 2 into outer diameter minus inner diameter. So substituting for these values, you end up with a value of 4.12 kilonewton as your actuating force. Again, just keep in mind that your actuating force is independent of the friction surfaces. It means whether you have one friction surface or two friction surface, that parameter does not appear in your actuating force calculation. However, when you're calculating torque is dependent on the number of friction surfaces that you have to transfer power or torque. So in this case, n is function of this equation. Looking at question 4b, what we have is we have a bend brake, and let's look at the information that is given to us. Right, the first thing is that it is rotating in the counterclockwise direction. So this is a very important qualitative information that you need to look for. It is rotating at a speed of 300 revolutions per minute. The coefficient of friction between the drum and the bend is given as 0.2, and a force of 500 Newton is applied to the lever arm as indicated over here. You are to determine the tension in the bend, that is tension in the tight side and tension in the slack side, and finally the power that can be transmitted. So when you look at this diagram, the first thing is you list the unknowns. So coefficient of friction was given as 0.2. Okay, so that's one piece of information. Now the other thing is, when you look at this setup, what happens is you can see the bend is lying on the drum, or it is embracing the drum within this angle. So what happens is you starting from here and going all the way over there. So when you look at this angle, it is simply 180 minus 30, because from here to here is 30 degrees. So this angle of embrace or the lap angle is 150 degrees. Most of the students make a mistake over here. Some of you will use 30 degrees, some of you, I don't know, you'll do 180 plus 30. But look at the diagram quite clearly, right? Sometimes when the bend is maybe, let's say, just like that, so the angle of embrace or the lap angle would be 180, because the bend lies on the drum in this region, and that will become 180. But in this case, at the given scenario, you have your rep angle on the lap angle is 50 degrees. So 150 degrees, converting it to radians, you get 2.62 rads. Now we know our tension ratio. Tension ratio T1 over T2 is equals to exponential F theta. This is not exponent, but this is exponential. It is it is a function that you can use in your calculator. So again, coefficient of friction was 0.2. Now your lap angle in radians is given as 2.62. So once we do this calculation, we get T1 over T2 is equals to 1.67. So therefore T1 is 1.69 T2. So that's one way of looking at things. So you can simply say T1 over T2 is 1.69, leave it as equation 1, or you can say T1 is equals to 1.69 T2. The next thing that we'll do is we will convert this to a free body diagram. So the question said that the drum is rotating in the counterclockwise direction. So counterclockwise direction is in this manner. So we have to determine which one is the tight side and which one is the slack side. So again, referring to our lectures, very simple understanding. What we do is we simply fix the bend. Assume the bends are fixed at this location. If this drum rotates in the counterclockwise direction, what does happen to this bend over here? So you'll notice this, yes, this drum rotates counterclockwise, you'll see that this bend is pulled. Whenever a bend is pulled, that becomes your tight side. So therefore this is your T1, and naturally the other side will become your T2. So this is what I have in my free body diagram. So I'm taking some of moments about point O. So O is over here. So distance of T1 is 150. Okay, distance of the applied 500 Newton load is 280 mm from the fulcrum, and then T2 is acting at 100 mm away from your fulcrum. Now the next thing is how to indicate the direction in which T1 and T2 are acting. Again, referring to your lecture notes, I'll mention it over here. Your tension in the belt will, the tension in the bends will always act away from the place where they are attached onto the lever. So when you look at this tight T1 over here, it is attached to the lever at this point. So the tension or the force will act away from where it is attached to the lever. So it will act in the upwards direction. So therefore my T1 is in this direction. So that's how I indicate. When you look at your T2, it is attached over here, and it will act away from that point of attachment. So away is in that direction. So that's why T2 is over here. Some of you will again say that why can't T1 be in this direction? It's obvious. There is no bend over here in this direction. There is no bend in this direction over here. So the only way it can act away from the point of attachment to the lever is acting in this upward direction and in this direction. So that is what is indicated over here. The next thing is I will take some of moments about my fulcrum point O counterclockwise to be positive. Again, you will notice that I'm using my dimensions in mm straight away. So you'll see that T2 will cause a moment clockwise, so minus T2 times 100, so minus 100 T2 plus T1 is going to cause a moment in the counterclockwise direction, so positive, so plus 150 T1, and then this 500 Newton force is going to cause a moment in the clockwise direction about point O, so minus, so the distance of the 500 Newton force from the fulcrum is 150 plus 130, which is 280. So I get my equation 2. So I already know that my T1 over T2 is given as 1.69. So again, it's just a typo of error over here. So 100 T2 minus 150 T1, when you know that T1 is 1.69 T2. So substitute this over here and you can solve for your T2. So T2 was 912 Newton and T1 is 1541 Newton. So this is how you will solve for your T1 and T2 using sum of moments, right? Then finally you have to find the power that can be transmitted. So power is nothing but your braking torque times your angular velocity. Your omega speed was given as 300, so your angular velocity is 31.42 rads per second, and your braking torque is simply the difference between T1 minus T2 times the radius. So T1 minus T2 times your radius, so your braking torque was 62.93 Newton meter. So substitute everything into this equation, you get a power of 1.98 kilowatt that is transmitted by this bend brake. So thank you for watching. I hope you understood. Again, I have talked about places where students make mistakes. So be very careful when you do these types of calculation. Thank you.